Solids. The first solid we'll deal with will be metals. Then we have mixtures of metals or alloys, then going on to ionic solids, discussing lattice energy, then covalent solids, and finally a number of different free response problems that are totally solved. Metals. Solids are formed when the forces of attraction between particles in a substance are high as compared to the thermal energy of the substance. If the force of attraction is high and thermal energy is low, the particles remain close to each other and there is very little movement. Solids have a fixed mass, volume, and shape. They have the least space between particles when you compare them to liquids and gases. They have fixed positions of the particles and are rigid and not compressible. There are three types of solids: metallic, ionic, and covalent. Metallic atoms lose electrons easily. They are easily removed. It involves an array of positively charged metal ions, these are these circles here with the pluses in them, surrounded by loosely bound electrons, and they're represented by the minus signs. There are strong electrostatic forces between the ions and the free electrons. Valence electrons become delocalized. That means instead of orbiting their specific nuclei, valence electrons flow freely in a sea of electrons around the positively charged nuclei. And that's what's being shown here where we have the lines here. This is showing the electron movement in between the various metallic ions. Metals are good conductors of heat and electricity. They typically have high melting points. They are shiny, malleable, and ductile. And they are readily alloyed. That means they can form mixtures with other elements. And here you can click for a nice tutorial on the properties of metals. Metals are good conductors of electricity because the electrons are delocalized and relatively free to move. They drift randomly around the lattice of nuclei. So here are the nuclei, these orange circles, and the free electrons are the light blue circles that are moving freely around the nuclei. Wires in electric circuits are made up of conducting metals, like copper. When an electric force is applied by a battery or a power company, the free electrons will move in the direction of the force. And here's the force pushing the electrons all in the same direction. This movement of charges is called a current. Metals are good conductors of heat. The lattice holds the positive ions close to each other, allowing them to transfer kinetic energy efficiently to other ions and the free electrons. Metals have a wide range of melting points. Due to high Coulombic attraction between the free electrons and their nuclei, their melting points are typically high. So in no particular order, we have platinum, which is very high. Sodium melts down at 97.8 Celsius, and lead is probably the next lowest. But you can see how they have that wide range, but it's still a lot higher than the melting point of water, which is 0 Celsius. Metals are malleable, and what does that mean? They can be flattened into sheets without breaking, and here's an example of some malleability here, and also ductile. They can be pulled into wires, which is very handy for copper wires that are used in electric systems. The atoms are organized into layers, which enables them to slide over each other when forces are applied. Transition metals tend to be hard and strong because of the greater strength of their metallic bonds. Examples include titanium, iron, and cobalt.